Hello everyone. In this video I will be covering projectiles, and I want to tell you that make sure that you understand free fall and constant speed movements before you get into this video. So a projectile is when you throw an object at an angle. Okay, so it's actually in two dimensions. Okay, so there's two elements that you need to take into consideration. And as you can see here, the ball is being thrown with velocity v at an angle theta. Okay, and what we need to do here is to decompose this into two vectors. A vector in the horizontal direction, v of x, okay, and we call it v of x because of the x-axis, and we decompose it into another vector called v of y, which is the vertical component of the movement. Okay, so vector v is v of x plus v of y. Okay, so if you remember from the vectors video, this is a triangular method, right? So v of x plus v of y is v. Okay, now instead of considering this movement, we consider this one and this one because it's easier. Okay, that's the general idea. So make sure you understand this. Okay, make sure you understand how we decompose the v into v of x and v of y, and why we do it. So let's consider each movement separately. So for now, we're going to care only about the vertical movement, okay? The vertical motion. So we're going to ignore v of x, okay? And just focus on v of y. So the first question you need to ask yourself is, what kind of motion is the vertical motion? It's basically free fall, right? Because there's gravity working on it. Okay, we're assuming that we're throwing the ball on Earth where there's gravity. So your vertical motion, your v of y, is a constant acceleration movement. Okay, so in order to find what v of y is, we have to use trigonometry. So we have angle theta, we have v. Okay, and just for clarity and for future videos, whatever information that we have, I'm going to show it in black. And whatever information we're trying to find out, I'm going to show it with red. Okay, so we have v, we have theta, but we don't have v of y. So what we do is we do sine is opposite over hypotenuse in a right angle triangle. Okay, so sine of theta is opposite, which is v of y. Okay, so sine of theta is opposite divided by hypotenuse, which is v. We have sine of theta, we don't have v of y, but we have v, so we're going to cross multiply, and we're going to get v of y is equal to v sine of theta. Okay, and acceleration, we already know it's equal to gravity, which is negative 9.8 meters per second squared. Okay, make sure you understand this whole procedure, and how you make sure is if you can take out a piece of paper and draw a projectile yourself and try to derive v of y without looking at the video, and make sure that it clicks in your head. Okay, I don't want you to memorize that v of y equals v sine of theta, because that's not going to work for you, because they could change questions. They could give you a different angle, right? Instead of giving you this angle, they could give you this angle here, and then you're going to just, if you memorize, you're going to write this and it's going to be wrong. Make sure you just understand the procedure of deriving v of y. Okay, there, if you do that, then you can solve any question. Okay, so let's move on to the horizontal motion. Okay, so in the horizontal motion, we're going to totally ignore the vertical motion. Okay, so we're going to drop it, and we're just going to focus on v of x. Now, what kind of movement is the vertical movement? The horizontal movement, sorry. We're going to assume that there's no air friction. Okay, so if we assume there's no air friction, then it's going to be a constant speed movement. Okay, because there's nothing stopping it in the horizontal direction. So in order to find v of x, we're going to do cosine of theta equals to adjacent over hypotenuse. Okay, that's the formula for cosine in a right angle triangle. So cosine is equal to v of x over v. Cosine of theta adjacent over hypotenuse. Okay. Again, we cross multiply and we get v of x equals v cosine of theta. Okay, again, we have v, we have theta, so we can actually figure v of x. Okay, and now we know that this is a constant speed movement, and we can use any formulas that you know for constant speed motion. Okay, so again, make sure you can do this on paper by yourself, and let's go through some examples. So problem number 1, a ball is thrown with initial velocity of 40 meters per second at a 30-degree angle with the horizontal. How high will the ball travel? Okay, this tip I've mentioned it so many times, but a lot of people ignore it. When you're trying to solve physics question, the first two steps and the most crucial and the most important ones are one, drawing a diagram, okay, drawing a diagram correctly, and number two is extracting information from the question. Okay, so let's do step number 1. We draw the diagram, we draw ourselves a ball, we draw ourselves the initial speed that it's thrown at, 40, and it makes a 30-degree angle with the horizontal. That means that if I draw a line here, this will be 30 degrees. Okay. Okay, at this point, we have drawn a figure, and now we're going to actually extract information. So how do we do that? It's asking how high will the ball travel? So I'm going to ask myself, do we care about the horizontal movement? Since the question is asking how high will the ball travel, that means movement in the y direction, right? So horizontal movement has absolutely nothing to do with distance traveled in the y direction, right? So no, because we want to find how high, right? So you see how much stuff we just extracted just from the question itself, right? So we're going to completely ignore v of x and we're going to work with v of y. Okay, so we're going to use the same formula, v of y equals v times sine of theta, right? Because we're using sine because sine is opposite over adjacent, and opposite of 30 is v of y, which is what we care about, okay? v of y equals v sine of theta. We do v of y equals 40, okay, which we replace v with 40, and sine of 30, which is half, so 40 times half is 20 meters per second. So v of y is 20 meters per second. We also know that acceleration is equal to g, which equals to negative 9.8 meters per second squared. And at this point, it becomes a free fall question, right? Because we have, we have acceleration and we have the initial speed of 20 meters per second. Now it just becomes a simple free fall question. And since we want to find how high it will travel, we can use vf squared minus vi squared equals 2g delta y. Okay, so I hope that you remember from free fall that at the highest point, the speed of your object becomes 0, right? So it's 0 squared minus 20 squared, which we derived up here, equals 2 times negative 9.8 times delta y. Okay, at this point, I'm just replacing the variables with the values that we derived. And, negative 400 equals negative 19.6 times delta y. We divide both sides by negative 19.6. And we get delta y equals negative 400 divided by negative 19.6, which will result to 20.41 meters. Okay, so really the projectile part of the question was just these three lines here with the figure, because we changed the whole projectile question to a simple free fall question, right? And you can only do this if you fully understand projectiles and how we change them into a vertical and a horizontal component. Okay, so I'll do one more problem. And in this one, we're saying a ball is thrown with initial velocity of 40 meters per second at a 60-degree angle with the horizontal. How far will the ball travel after 2 seconds? Okay, again, first step, let's draw it, and let's draw it carefully so we don't make a mistake. So we have a ball, initial speed of 40. It makes a 60-degree angle with the horizontal, correct? I automatically decompose it into the horizontal and vertical components. Okay, and then I'm going to see what the question is asking. How far will the ball travel? So do we care about the horizontal movement? We're talking about how far. How far means in the x direction, right? So of course we care about the horizontal, right? And does how high up the ball go affect how far it goes? No, so we're going to just care about the horizontal here. Okay, so we're going to write the information that we have. First, we're going to derive horizontal speed, velocity, right? So we do v of x. So now we have 60. Opposite of 60 is v of y. We don't want that. We're going to use adjacent of 60, which is v of x. So we're going to use cosine. Okay, so v of x equals v times cosine of theta, which is, okay? So v of x equals 40 times cosine of 60, which is 40 times half, which is 20 meters per second. Okay, and we're going to remind ourselves that in the horizontal direction, speed is constant and there's no acceleration, right? And the question also gives us delta t equals to 2 seconds, right? How far will the ball travel after 2 seconds? So right now we took the question, all of this, we changed it into a diagram and 4 mathematical statements, okay? And now we can use the formula for constant speed movement motion, which is delta x equals v delta t, okay? And we don't know what delta x is, but we have v of x and delta t. So v of x is 20, delta t is 2 seconds, and delta x will be 40 meters, okay? I hope that this makes sense. Make sure that you can actually do this yourself. Now, for the last problem, until now we had one problem which only focused on the vertical movement and one problem which only focused on the horizontal movement. In this problem, I want you to try, it actually uses both. So you need to extract some information from the horizontal, from the vertical, and use it in the horizontal. Okay, so a ball is thrown with initial velocity of 40 meters per second at a 60-degree angle with the horizontal. How far will the ball travel before it hits the ground? Um, try your best to solve this problem. Hopefully I will solve this for you in a subsequent video and make sure you understand it. I hope this video helped and good luck.